expected future improvements should primarily come from the increase in data and not from the improvement in the algorithm. We suggest you stop your development at once today, because whatever you're building, you're going to throw it away down the road anyway. These mistakes and misconceptions come from the typical software development mindset. When you're building a competitive advantage, you should train your own model. Your AI models should not be easily transferable across domains. And eventually, the niche got dominated by the company who understands the game best and not by the company who shows up first. The company who shows up first just exposes the opportunity.
And now we are discussing the best practices and the best ideas for implementing AI. But I'm sure that you quite well know that common mistakes people do when enter AI. Can you please share some of those mistakes? Very common.
Yes, absolutely. I'll focus on the mistakes on the journey for building a competitive advantage. Those mistakes that I'm gonna list, they are not mistakes when you're using AI as an enhancer. If you're interested again in improving the bottom line, cutting costs, automating some processes, these are not mistakes. These are actually the way to go for you. But if you're thinking about using AI as a competitive advantage, if you're interested in the game of Blue River in Google search, then these are mistakes. So that's my initial, that's my starting point. And interestingly, the common mistakes that happen that companies do when they're building a competitive advantage, these mistakes and misconceptions come from the typical software development mindset. That's an interesting observation, which we've been kind of surprised to see that, but often the companies who are excellent at building conventional software, let's call it this way, and who map their way of thinking from the conventional software to the AI businesses, AI models, AI competitive advantage initiatives, they do that wrong, and sometimes gravely wrong. So sometimes it's just obvious that they're going to fail from day one, right? So the mistakes that I want to mention, the first one would be using third-party AI products. When you're building your own competitive advantage, it's crucial that you are actually training your own model with your own data and not using anything other than third party. You can't buy competitive advantage. That's quite straightforward, right? If you can buy something, then your competitor could buy that as well. More to this point is that whenever you buy any technology and apply it for your business case, that gives the vendor of that technology, the vendor of that product, a perfect case study which they can use to approach your competitors, companies similar to you, and try to sell them the same product, showcasing your use case. So whenever you buy a product, whenever you buy an AI product from a startup or established companies and so on, you showcase them how your business in your specific industry could benefit from that technology. And the immediate response from the vendor is to approach similar companies similar to you, and try to sell them the same product, explaining how you get value from that product. So whenever you are buying an AI product, you must be absolutely aware that you help, and this decision actually leads to more and more adoption of this product across your competitors, leading to the point when everybody uses this technology. And when everybody uses the same technology, that means there's no differentiation. You started with, for example, there's a market when nobody uses AI, right? Like 100 companies, nobody uses AI. They started buying AI products, say adopting ChatGPT, right? At some point, they all adopted ChatGPT. They end up at the point zero. Now they had no differentiation. Now they all adopted ChatGPT. They still have no differentiation, right? They might cut some costs on this journey, but they still compete against each other with other means, not with AI. And the cost that they cut actually eventually got distributed between their customers and OpenAI. These companies, in the economic terms, they don't get much benefit from that. I'm not going to dive deeper into the economic terms and economic models, but the whole point is that you can't buy a competitive advantage. That's the contradiction in terms. A competitive advantage can't be for sale. I mentioned that this mindset comes from the conventional software engineering mindset, which means if you could buy a tool, you should buy a tool, right? If you could buy Jira or Confluence or whatever, you should buy Jira or Confluence. You shouldn't build your own Jira. It's quite clear. But if you're building a competitive advantage, you can't really buy it. That doesn't lead you to where you want to go. The second mistake is harnessing pre-trained models. The point is quite similar. There are wonderful repositories of pre-trained models, source models, such as Hugging Face, for example. We love Hugging Face. We use Hugging Face on a daily basis. But it's important to keep in mind that you can't just download a model from Hugging Face and hope that that would lead you to a competitive advantage. Obviously, when you are buying the third-party product, your competitor could do that without any expertise whatsoever. They just approach the same vendor and they buy the same product. When you download the model from Hugging Face or when you deploy a third-party pre-trained model in any other way, that means for your competitor, that takes a little bit of technical expertise to do the same. How hard it is to replicate what you've done? Well, a little bit harder comparing to buying the ready-to-use solution. Subscribing to ChatGPT is easier than downloading Llama 3 and deploying it. But really, what stops you from doing so? Well, a skilled engineer maybe, and that's pretty much it. The logic holds here as well. When you're building a competitive advantage, you should train your own model. You can't build a competitive advantage on the third-party models, open source models, open access models. It's just not how it works. You can start from that model, and that will be fine, but you need to train this model further with your own data. You can't have an AI competitive advantage initiative system or product built entirely on the third-party models. Now, the third mistake would be relying on open datasets. The point is pretty similar. It's like we are going downwards, right? Subscribing to ChatGPT is the simplest possible way forward. Downloading a model from Hugging Face takes some engineering expertise, but still easy to do. Now, you might say, okay, what about I'm training a model, but I'm going to use an open access data set. There's a wonderful data set out there. I'm just going to train my own model with this data set. It doesn't work this way because your competitor can access the same data set, right? They can train their own model with the same data set, and since the data is the king, you will end up having pretty similar models. The fourth mistake would be a weak feedback loop. The example with Google search shows how important is the feedback loop. Whenever your user clicks on the web page, this is actually the feedback loop in action. That gives Google the data they need to retrain the model. They cannot retrain the model without knowing what was the page that you actually wanted to see, that you actually wanted to go, right? And when the user journey doesn't provide this crucial piece of information, this crucial piece of data, it's quite hard for you, maybe next to impossible, to improve your model. And by weak feedback loop, I mean that if your user journey gives you a right piece of data in, say, 10% of the sessions, and your competitors could come up with the user journey that gives you right data, say, at the 30 cases, at the 30% of the sessions, that means they are moving faster. On average, per session, they get more valuable data than you do, and they can eventually outpace you down the road. Now, that's on the technical side. On the cultural side, we are talking about the engineering culture, right? There are a couple of very logical, very straightforward things about AI that might be surprising when you think about them from the engineering standpoint. So the first truth about AI is that implementing your AI models with a limited amount of data should be hard. and the initial version quality should be inferior. This is something that doesn't come around the typical engineer, right? It says that whenever you build a system, it shouldn't work well. The initial version shouldn't work well. If you're an engineer and you've built a system, it works well from the beginning, then you're a great engineer. But if you're building an AI competitive advantage and you got a handful of data, you train the model and it works perfectly well, that's a red flag, really. Because that means anyone can use just a handful of data, and that would give them a fully functional model. There's no mode, right? You don't need much of data. That means for your specific use case, for your specific type of data, for your specific application, you don't need lots of data. And lots of data is something that actually creates the moat, creates the competitive advantage. So that's first misconception. That's first thing that might not sound or look reasonable to the engineer from at the first glance, but it is perfectly reasonable when you're thinking about a competitive advantage, about the point that you're building something that shouldn't be easily replicated, that could not be replicated easily. The second truth, unobvious truth, is that your AI models should not be easily transferable across domains. Again, if you're an engineer, you've built a product, you've built a system which works perfectly fine for, say, logistics and finance. It's useful, it's applicable for both domains. Then you're a great engineer. You've built a great product, right? You can sell them to financial companies and you can sell it to logistics companies as well. But if you train your model, your AI model, with the data from the logistics industry, and then this model is transferable to the finance industry without having much data from the finance industry, that means someone else might train the model on the finance industry and transfer it to the logistics industry, or maybe they may train it on some third, even yet different industry, and transfer it back to the finance and logistic industry. That means some other company in a completely different industry without access to the data of your industry can build and train a model that is applicable for your industry. So it's a red flag, right? Because you might be unaware about those companies or might be aware about those companies. But the whole point is that in this case, in this situation, you don't need the data from your industry to build the model applicable to your industry. That means there's a flaw, there's a threat for your competitive advantage. Someone could show up from an entirely different industry, bringing up the model that's applicable for your industry, and that's your threat. That's a threat from the competition standpoint. The third point is that, again, that's crucial. That's extremely important, and I just can't stress how important is enough. The expected future improvements should primarily come from the increase in data and not from the improvement in the algorithm or in the model. Which means whenever you're building an AI product, a truly AI business, an AI competitive advantage, you should think about how you develop it further, how your product is going to be better. It's not about, I'm gonna hire 20 or 30 machine learning researchers and they will figure out a better model for me. They will build a more complex, more sophisticated neural network. They might, but that should be a sideshow. The primary focus for your roadmap should be, how do I get more data? Because again, the data is the king. Whoever owns the data ends up with the best model. And you should adopt that as your product management thinking, product management approach. How do I ensure that I'm going to get the best data down the road? Not the best models. That is a call to the executives as well. How do you manage your investments? Would you invest in research and development for researching and building best models, best new architectures, or would you rather think about how do I get more data from maybe tweaking the user journeys, maybe entering new markets, whatsoever? The right way of thinking must be, we expect the future improvements from the increase in the amount, in the volume and the quality of data, rather than we expect the future improvements from the improvement in the model architecture. The last, I guess, an obvious truth about the AI products and AI competitive advantage is that AI business has the fastest and not the first mover advantage. This is again crucial. We touched that briefly. We touched the fact that it's not being the first on the market that guarantees you success. It's the understanding of the game. And very often we see the situation when the startup, the first comer, exposes the niche to those who know the game. And then those who know the game show up later, but they know how to outcompete those first comers. And eventually the niche got dominated by the company who understands the game best and not by the company who shows up first. The company who shows up first just exposes the opportunity. It's crucially to know and remember that whenever you explore or even invent a new market, there are hundreds and thousands of people looking at you right now and thinking how they can grab this market for you and push you out of this market. And with AI, the winner is not the one who shows up first on the market, but those who acquire the data at the fastest pace. Whoever understands how to build those user journeys, how to build those data acquisition models best, they end up with the best machine learning models, AI models, and eventually the best products on the market.
You say you cannot buy a competitive advantage, and it reminds me a story when a person is watching TV and TV says, "Do you want to be rich and famous?" Yes, of course I want. Or do you want to have a million of ladies around you attracted to you? Yes, of course I want. So step first. Get away of your coach. What? Get away from my coach? No, that's not my method. So I have another fun citation for you. We have CEO who comes to their employees and says, "Guys, I found out the brilliant AI tool and I want you to include it into our corporate strategy. And I don't care if you like it or no, I just want it to be here inside." And here is my question. What exactly team is needed to work on AI products implementation? Is it enough to have just one CEO or no?
Yeah, the one you described is the complete disaster. The approach you described is so typically a complete disaster. That's the total end button, and I've seen that very closely, firsthand, when the CEO, the visionary leader, shows up with the next shiny tool and forces the entire company to work on this new shiny tool with the goal, with the objective to, well, raise another round from the investors, and that becomes the ultimate goal, right? Your goal is not to build the great product. Your goal is not to build the competitive advantage. Your goal is not to win the market. Your goal is to raise the next funding round. And whatever new shiny tool could help you raise the new funding round becomes your obsession. But that never works. Well, that might work a little bit, but that's a gamble. And if you're really not into gambles, then you should do it differently. The tango of AI competitive advantage takes two, and those two are the product management and the AI team. They need to work closely with one another because you can't build the AI competitive advantage without them being jointly involved. Because the product management, they are responsible for the user journey. And the user journey is exactly where you get the data. The user journey defines the touch points between the users and the product, and those touch points are exactly what gives you data. Those touch points might be anything from clicking on the button in your software as a service application and up to a person, a customer showing up to the bank physically to make a wire transfer or open or close bank account. Each of these are the touch points. Each of these are parts of the user journey. And the user journey generates data. Sometimes it happens so tweaking the user journey slightly without compromising the value might help you get a crucial piece of data, a crucial piece of information that enables additional set of AI models. And without product management involvement, you just can't think of it. You can't do that. You can't make it. The AI people might say we need this data, but how do we get this data? They need product managers to do that. Now, on the other hand, product managers need to understand what AI tools are there. These days, we are living in the hype bubble of the large language models, and whoever says AI instantly imagines ChatGPT. But the tool set is incredibly rich, and it's way more than just large language models. We have regressions, we have classification models, we have anomaly detection, we have clustering, we have time series analysis, we have lots of stuff. And each of those models, they could be trained with the specific data. They all require different data for being trained. So understanding which models are there, which models are available for training, which data should be used to train these models, and crucially, how those models can improve the perceived product value. Because again, the perceived product value is the realm of the product management. They know what the customers and the users see as the value. They know if they improve this particular feature, that would have a great that would echo positively across the customer base. But if they improve another feature, feature B, for example, the customers might not even notice. This information about which feature is more important to the customer and which is less important to the customer may be not very obvious to the engineering team, maybe not very obvious to the AI team, right? Not to mention that the product management team, including the senior leadership, is responsible for the product roadmap. They know which markets and which niches they want to expand to. They know what features they plan to ship and when. So they need which of the functions, which of the features, and which of the products, if you're thinking about the product line, needs to be reinforced with these AI enhancers first. And it's only in those sequence of steps from both sides, from the product management and the AI team, you it's the journey that they should take jointly, hand by hand, if they want to arrive at the final destination and actually build, envision, design, and build the AI competitive advantage cycle.
Thank you. AI market now is hotter than ever, and beside of those giants or major companies that you mentioned, we have a lot of startups that are going to enter the market with kind of AI tools implemented into their strategy, maybe like ChatGPT you again mentioned, like something small but still AI to add extra value to their businesses. And sometimes those companies did not have enough resources. I mean, first of all, technical expertise to fulfill their needs of this AI implementation. Can they survive on the market? Maybe you can give them several advice.
Definitely so. First of all, the talent pool has been global for quite a while. You can find talent across the globe. You can find talent in different geographies, and thanks to COVID, although that sounds controversial, but thanks to COVID, we have the culture and the tool set for remote work that is quite effective and quite efficient. And second of all, you need the right guidance. I strongly believe in the right guidance. The engineering team might be great, but you just need to make sure that you understand the goal. They understand the goal. They understand what they're building. Otherwise, you might spend tremendous amount of money in-house or with the third-party partners and end up with something that doesn't really build a competitive advantage and something that could be easily copied and will be easily copied by the company down the road.
Is there any industries that are easier to enter for the small companies? For example, I know that healthcare now is a golden mine, and healthcare is very attractive for those who are creating AI startups because of the problem of diagnostics. Diagnostics is a trouble because human doctors can do errors, and their patients have to struggle because of these errors, and AI can analyze a lot of data and help people to get the right diagnosis. So if healthcare is a good niche or vertical for these new companies, newcomers, or maybe any else directions.
As someone who's been building the AI product for the biopharmaceutical research, I guess I can advise against this vertical, this industry. It's tremendously hard to penetrate. The data is in a very limited and managed access. Sometimes there are regulations you might not be aware of. Just to give you an example, We are DeepTrade, the company that I co-founded, builds the tool for analyzing next-generation sequencing data. This is a specific type of genetic data, and in Europe, one of the largest markets for the NGS data analysis is Germany. Right. Well, Germany is the powerhouse of Europe. They account for roughly 20 or so percent of the European economy, and obviously they have lots of data and lots of interesting use cases. Hospitals such as Charité and Vivantis, they are household names across Europe. Right, they are the best, probably one of the best in Europe, and they are they are excellent. They are absolutely at the topmost quality level across the world. They are sitting on the gold mine of data. That's absolutely true. But you may never know that until you hit this wall. But Germany prevents and explicitly prohibits any processing or storing of the healthcare data in any non-European or ideally non-German cloud provider, which immediately rules AWS, Google Cloud, and Azure out of table. And when you are building your product in the cloud, and say in AWS or Azure, or sorry, yes, AWS or Azure or Google Cloud, and then you show up to any German clinic or any German customer, healthcare company, right? You might have a wonderful product, but they say we just can't upload our data to any of those clouds by the regulation because the healthcare data. Can you maybe deploy your product on premises? We have those servers, or maybe you should use one of those European data centers. So you might go this way, but that imagine how hard it is to launch your first pilot projects if you need to deploy your entire application in Germany for German customers, in France for French customers, and so on. Clouds are wonderful tools for early stage startups, but sometimes, and especially in healthcare, they are just not applicable in the places when you would expect it to be. US is a different thing, but US is much more competitive on that side. If you're looking at building an AI company with the AI competitive advantage at heart, I would suggest you look at the internet data. Any data that exists in the internet, any digital data is readily available for you, especially in the B2C market, when you can easily get individual consents, at least in a fraction of the cases, and that would be enough for you to build your models. This case, this situation might actually bring you to the viable business faster than a long and lonely healthcare journey. With the value and the impact in mind, obviously healthcare is one of the most impactful fields. And it's a pity that building something for such an impactful field these days is such a complex endeavor.
So, your company, Shelpuk AI Technology Consulting, develops strategies for companies to help them implement AI and explore its potential and get the most from AI. What those companies should prepare before they call to you and ask your help? At what stage of their business is it better for them to reach out to you and ask for your help?
Internally, we map the projects, products, and customers in one of three buckets based on whether the customer knows the problem and whether the customer knows the solution. If the customer doesn't know the problem and doesn't know the solution, the scenario would be someone approaching to you and saying, I'm very interested in AI, but I have no idea how to apply it to my business. We map such cases in the bucket one, which we call consulting. We explain to those customers the idea of the AI competitive advantage. If they already have their business, we engage with them as consultants to figure out, identify an opportunities for building those cycles, or to audit their existing AI initiatives that are under development, for example. If the company doesn't have the existing business, or they're thinking about starting a new business, a new product, we help them with the customer development. We have a wonderful framework from in CEAT, French Business School, which we establish and apply and polished internally for customer development, for value proposition design. So if you have an idea, if the customer has an idea about a new product or a new business, but they are not sure whether there is a place on the market or what would be the actual customer needs, on the market. We set up the interviews, we conduct those interviews, we synthesize the insights, we iterate, and we, in a couple of weeks, up to 2 months, we end up with the verified and validated value proposition for the customer. And obviously, customer is with us along this journey. They go with us to those meetings, they learn from us, we explain them what we do, we explain them how they can apply it further. That's the consulting side. If the customer knows the problem but doesn't know the solution, for example, the customer wants to build, say, the conversational agent that would know the European regulations on import and export, right, or something like that, and they want this conversational agent to be a virtual lawyer, let's say, for their customer base or user base, but they don't know how to build it. We help them design the product, design the solution. That starts with the designing the product itself. I'm not talking about UX design. Normally we don't touch that. I'm talking about the customer journey design and the technical design. Although my expertise lies in machine learning, I've been in this field for the last 13 years, but I'm also, say, Google certified cloud architect. I know pretty much everything about Google Cloud and other clouds. I know not just how to build and train those AI models, but also how to deploy them, how to make them useful at scale, and how to cut costs with the production execution to the bare minimum. That's the second bucket for us, which is the product design. And the third bucket is when the customer knows the problem and knows the solution. This scenario would be someone who wants to build anomaly detection system, right, for the complex industrial machinery, the complex industrial setup. And they have lots of various data from various machines, including imagery data, sensory data, and so on. They have the team which works on this problem already, but they need just an extra head or an extra couple of hands to reinforce the team. This way, in this case, in this scenario, we inject our own expertise. We join forces with such companies, such customers, to help them build what they're building faster, cheaper, sometimes even of better quality.
So, to finish this beautiful conversation in the most bright way, can you share any stories or maybe success stories or case studies how exactly you helped companies? By the way, guys, if you would like to learn about case studies of Shelpuk AI Technology Consulting, you can again open the link to their website and find the section with case studies. So please, Sergei, can you share any bright examples?
Since you mentioned the case studies and the website, I'd like to share the one which is not on the website. Hopefully, that will nicely conclude the conversation. The customer, a couple of years ago, the customer approached to us with the consulting request for auditing the AI product development they've been doing. The customer was building a startup for the transportation industry. The founding team was working in the transportation business for quite a while, and they knew that, from data as well as from the personal experience, that roughly in 50% of the truck drivers drive while being intoxicated, mostly alcohol, at least once a month. And the problem, well, you can search for that. The problem is that whenever the truck hits, say, an infrastructure, say the bridge, the insurance company doesn't cover the damage if the driver was intoxicated. And for the small to medium transportation company, that often means immediate bankruptcy. You may imagine a case when the truck hits the bridge somewhere in Germany, for example, and now the transportation company needs to pay for rebuilding the bridge plus compensate for all of the cargo and the damage they've done and other things. Most of them don't have that money, and that means it's just easier to close the company down and maybe start a new business. So the founding team envisioned the product, which would be a mobile app, which takes selfies of the truck drivers and classifies those selfies into sober versus intoxicated, right? The journey, the The use case would be as follows. The truck driver wakes up, gets into the truck, takes a selfie. The system then says whether the face looks sober or intoxicated. If the app says okay, then the driver can move on, and otherwise the app should inform the transportation company about that. They hired an engineering team, an offshore engineering team, and that was the great engineering team. I have no comments or complaints. They were absolutely skilled and very competent engineers. They've been building this system for quite a while, but since the founders were not proficient, they didn't have personal expertise with AI. They hired us to do the audit of the engineering team work and project. We talked to the engineering team. The engineers told us like the following. The problem of telling apart sober and intoxicated faces is the image classification problem. So we need the model, a machine learning image recognition model, which would be the best in the image recognition. And we know that there are certain models, I'm not going to drive you into the technical rabbit hole. There are certain architectures that are state of the art, meaning they provide the best performance on this task for certain benchmarks. And we will use these architectures. There's been certain convolutional neural networks. Now, these models need to be trained with the data of sober and intoxicated faces, and obviously we don't have the data set. So the team figured a data set in managed access, which means the data set is there, but you need to apply to get the access. They applied for the access, and while waiting, they scrapped Google image search for the face images. They gathered the medical protocol for visual diagnostic of sober versus intoxicated faces, and they even hired a contractor for labeling the scrapped data with sober and intoxicated faces. We looked at all this and we went back to the founders, to the board, with the conclusion. We said, let's consider, how do you imagine the application of your product? How do you imagine this product is going to be used? So the truck driver gets into the truck, takes an image, and drives on or doesn't drive on. Now, the model that your team picks up for training, for telling apart sober and intoxicated faces, it can be trained on the data that needs to have two crucial properties. First of all, it needs to be a balanced data. In a perfect world, that would be 50-50 split, meaning 50% sober faces, 50% intoxicated face. It can be like 70-30, but it can't be like 99-1, right? So you can't have this model trained if you have 99% of sober faces in your data set and 1% of the drunk or intoxicated face. And second crucial feature of this data is that it should be labeled. For each image, you need to have an attribute, whether this image represents a sober or intoxicated face. Now we say, think about what data your product is going to be collecting when you release it on the market. The truck driver takes the selfie and goes on or doesn't go on. First of all, the whole world around us tells us that most of the time the truck drivers are sober. If they were mostly intoxicated, or if they were intoxicated in 50% of the cases, the world would look way more dangerous than it actually is. So we can be sure that in most of the cases it's going to be sober faces, which violates the criteria number one. You're going to have an unbalanced data set. The data that your product is collecting is going to be mostly sober faces. Criteria number two, you need to know whether this face is sober or intoxicated. And whenever your truck driver takes the selfie, he or she doesn't take the blood test at this very moment, right? So you don't really know whether this face that is on the selfie is actually sober or intoxicated. So the data you are collecting, the data you are going to be collecting with your product is going to be unbalanced and unlabeled, which means you can't use this data to improve the model you are building right now further. That means this model could maybe take you to the MVP, but no further. And down the road, you are going to throw this model away. Now we say, let's get back to the user journey. Think again about this truck driver. He or she wakes up somewhere in the motel or in the truck, takes a seat, takes the photo, moves on or doesn't move on every morning, every morning. So the data you're collecting is the faces of the same person over and over again every morning. And your problem really is not to tell apart sober versus intoxicated faces. Your problem is to say whether today the person looks significantly different than on average. And that could be casted as the anomaly detection problem, not the image recognition, but anomaly detection. And we have anomaly detection models for the images, and the anomaly detection models could be trained with unbalanced and unlabeled models. So our conclusion was like that. We suggest you stop your development at once today, because whatever you're building, you're going to throw it away down the road anyway. You are in some way, in some sense, you're wasting your investment. Instead, start building an anomaly detection model. We know that you don't have the data. You can follow the Blue River path, but instead of taking the images of cabbages and weeds, you can take a selfies, right? Every morning of the founding team, and you can go to the bar on Friday to make sure you have some outliers in this data set as well. The initial model is not going to be perfect, but as soon as you have the first truck drivers using your product, you start getting data that could be used to improve your model. And you can actually use the data from the usage, from the product to make the product better, which leads up to building a competitive advantage.
Thank you, Sergii, for this very insightful and very interesting conversation. I believe it will be very helpful to our audience. Thank you guys for watching this episode of JSP Coffee Podcast with Sergii Shelpuk, who is the leader of Shelpuk AI Technology
Thanks.
Consulting.
Thank you very much for inviting me. It's been a great pleasure, and looking forward to seeing you next time.
So please go to their website using link from description to this video, and maybe those guys will help you to implement your best AI ideas in the world. Thank you for being with us. Have a great day. Cheers.